In the last video and this video, we've been looking at web analytics. So getting data from web sources, from social media accounts, or from information collected on who visits your website. In our previous video, we looked at YouTube as an example in terms of collecting and analyzing information about our customers or those who visit or interact with our site, who comes to your TikTok channel, who visits your YouTube channel, who comes and buys things or looks at your company website. In this particular video, we're going to look at Twitter. So what we're doing here is looking at what type of data we can collect from Twitter or X, or other websites like Facebook, where you are collecting information where people are providing text. So the previous video was about demographics and who visited the site. Now let's look at pulling information that is more text, opinions, comments, messages, and what we can do with that. So we're going to look at Twitter or X as our example here. So the first thing is that whatever social media you're using, you have to figure out how to export the data. When it comes to exporting Twitter data, you log into X or Twitter, then you click and tap on More, select your settings and privacies, choose your account, select Download and Archive of your data. What it then does is ask you to confirm and you request your data. It actually takes a couple days before your data appears between when you make the request and when it is available to you. So just keep in mind that you can just immediately export your Twitter data, unlike, say, your YouTube channel data, which is just downloading a CSV file and takes 2 seconds. So keep that in mind, that there is this delay between when you request and when it becomes available to you. When you download your Twitter data, what it gives you, actually, let's just go here. Oh, no, this. Okay, what you get is you get a document with all your files, and this document here lists all the different types of files that you get. So you can understand in terms of what information is being conveyed. So we can have account information, we can have information that contains likes, that contains direct messages. There is information in terms of ad engagement. So what tweets did you promote? So someone got an advertisement, did you look at it? So your impressions here as you viewed it, did you engage with it? And so we're tracking what companies that you're actually engaging with who are advertising on Twitter. We can also look at information about what other apps you use on your device. So recognize that when you have an app, whether it's like Starbucks app or Twitter app, it actually does track what other apps and other things you're doing on your phone. And so that information is collected and you can output it here for Twitter. So there's a lot of information. There's information on who you blocked, and there's information on your, I don't know where it's in here somewhere, but who your followers are and who's following you. So let's take a look at what we do with this information. So we have a bunch of these JS files is what we have, and there's tons of them. I've just only included a couple here. But if you want to follow along with us, we are at drstephpowers.github.io/BIA. And we are here under Chapter 7, Data Sources, Web Analytics. That will give you this Python workbook that we are working on here. And so we need a way to pull in those files, right? So we have these .js files, and these JS files are actually JavaScript. So the problem is we want to pull them into Python so we can use that information and do some analysis, but it's not in a format that is conducive to importing and analyzing. So we just need to do a couple tweaks to make it so that we can. So if we look inside, actually, let me just pull one open. If we look inside these JavaScript files, here's what it looks like. So in this particular one, what it's looking at is other apps that you use. Starbucks app, LinkedIn, PayPal, Twitter, Twitch, Subway app. These are other apps that you have on your phone. And so what if we want to pull this information and collect and analyze this information? Well, the format it's in currently is not conducive to that, to nicely pull it in to Python. But it turns out that just a couple of tweaks will turn it into the equivalent of a JSON file. And a JSON file has similar structure here in terms of these kind of like subcategories that are here, and then the data that's attached to them, and similar layering. So what we're going to do is we're going to take our file and we're going to make a couple tweaks to it. So you can see here that the JSON file, let me just pull out here. The JSON file, or sorry, the JavaScript file, for example, the one that's called like, starts like window.ytd.like.part0 equals hard bracket. Okay. In order to make this so we can open it as a JSON file, what we need to do is we need to remove that first line, that window.ytd.like.part0 equals hard bracket, and then start with a curly bracket and then a word that's in quotes. And what I do is I just pick one word that I like and I do it for all of them. That way when I quick glance inside my JS file, I know whether it's already been converted or not, because I'm looking for some random word at the very top. So in this case, I have a curly bracket, I have the word books in quotes, a colon, and then a hard bracket. Then the rest we can leave as is, with the exception of at the very, very end of the file, you need to add a curly bracket. So if we go back in, so the original version has a hard bracket at the end. What you do is open this with some text editor, just go in, hit return, and add a curly bracket at the end. Okay, so we're adding a curly bracket at the end, and we're replacing that first row so that we can import it into our system here. Okay, so for this case, we start with this first line and a hard bracket at the end, and we're going to then change it. We can see here we've added the hard bracket, and we put in the curly bracket at the top with a word in quotes, colon, and then a hard bracket. So we're moving that equal sign. If you don't do these exact changes, when you go to try to port it in, it will complain and give you an error. So I'll do this change and then I'll be like, oh, I forgot to remove the equals right here between the colon and the hard bracket, and it doesn't work. So make sure that these are the changes: curly bracket, then a word in quotes, then a colon, then a hard bracket. So that's replacing the first row of whatever you had in there, and then a curly bracket at the end. When you do that, what you can then do is have Python treat it like a JSON file. So in which case, we're going to import JSON. And then to import a JSON file, we're going to do with open and then find your file. Mine happens to be in my BIBA handbook folder, in the chapter 7 folder, and then in a Twitter folder. And then I have my like.js. If you're getting these files and putting them into your Google Drive, you will find these files by clicking here under Web Analytics, going into GitHub, and you can find these files here where it says data. You can pull whatever JS files you want and then put them somewhere into your Google Drive. And then we want to link to that. So don't forget, if you are doing this, you will need to mount your drive. So you'll need this command here to connect your workbook with your data, which of course means you need to open your workbook in Google Colab and save a copy so that you can actually do that editing and running that code. So let's just go back through here. This was from last video. All right, so how did I end up right back at the top? Let's go back down. Twitter. Okay, so with open location, this R means we're reading the file as opposed to writing the file. If you were writing, you'd be putting in information into it. We are simply pulling information out of it. And then we just do as and then a letter. Then we're going to call this data and we're going to do load JSON. And then we need to normalize it. So the purpose here is to define what it's looking for. So this first part, data books, whatever you pick as your kind of header that you use to symbolize that you've changed it, data books. Then the next part is going to be, if we look at the hierarchy of our image here, notice that we have books and then we have like. So, and then within like, there is Twitter ID, full text, and expanded URL. So when we put that into Python, it's like, and then tweet ID, that was the name. And these are all in hard brackets, and then like full text. and then like expanded URL. So it's saying that expanded URL is within the like, full text is within the like, and tweet ID is within the like. So you want to make sure you have replicated this formatting, and all you're simply doing is pulling the names from this. So like, tweet ID, full text, expanded URL are the different labels we need to pull for our code. Okay, so what we do is we run that, and then we say, okay, well, show us the DF, the data frame, because that's what we called it. And now you can see it has taken our information and it has given a tweet ID. That's the individual that we liked. And then we have the text here, and then an expanded URL. We don't really need the expanded URL, but the benefit of this full text here, and we could do this for likes, we could do this for direct messages, and what we can then do is use our text mining, and we have videos on how to do text mining to analyze this. We could pull all these comments and put them into a word cloud or a word tree. We could do a keyword search. We could better understand what this text is saying. And then to build on that, we could do sentiment analysis, and we have a video on how to do that. So you could take all of these comments and we could analyze the sentiment. Is it more positive or negative? And we could also go even more extreme, as we could use our convolution neural networks to analyze sentiment in more detail. So we have a non-neural network video on sentiment, and then we have our neural network method that's a bit more complicated. So we could take this information and analyze it in a lot more detail to better understand what is being said here in terms of the text. So take a moment, practice importing these Twitter files. So there is a file called app.js. So take that file. You'll notice when you look at it, unlike this one, which I have already converted, go and do this app.js, it needs to be fixed. So we need a curly bracket at the top. We need to replace this row with a word in quotes and a colon and a hard bracket. So make sure you remove this equals. And then we need to make sure we put the curly bracket at the very end. If there's no curly bracket at the end, it won't import. So give it a try, pulling that one in to the system here. I got too many different things open. Okay. Now, I want to show you something else that you can get from Twitter information. So besides collecting information for our text mining, and we'll look at text mining in more detail later, the other thing we could do is we can collect information about the individuals that we follow and those who follow us. So there are two more files that are available here, follower.js and following.js. So if we convert the follower.js so that it is correctly with the curly bracket at the top and books or whatever you want in quotes, colon, hard bracket, and then adding that curly bracket at the end. If we do that, import this in, we again need to have the labels. So it's always good to open it up. So let's look at which one are we doing here. We are doing follower. And you can see here, I've already changed it. So curly bracket, books and quotes, colon, hard bracket, and at the very bottom, scroll, 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 scroll. At the very bottom is the curly bracket. But notice what it has here is it has follower, and then for each follower, it has an account ID and a user link. What we want to do here is we want to pull these account IDs. So what we would do is we would say data and then books or whatever your label is that you like. And then we have follower, and within follower is account ID, and within follower is user link. So we need to make sure as we import it, for it to import properly, it has to match. So here we have account ID and user link. The benefit of this is that we can actually build what we call network models or graph models or network graphs. These are all different terminology that are used to show how information is shared. So if you pass on information to a follower, they have people that follow them, that information moves to them. We can actually show the flow of information and the connections of people. And so we have a couple videos related to network or graph models about how that works and creating that visualization and and analyzing it. So what you could do here is you could take these account IDs. Well, what you're going to need is you would need this account IDs. You would also need information about those who are following. So followers, following. So we can have, that would give us 3 nodes on our network. And I'll just show you, just open up here. Just give me a quick second. So I'll show you in terms of what we mean by a network graph. Just go into the slides from that video quick. As soon as we figure out where we put it, network models. Okay. And so we can take this information and we can build something that looks like, could build something that looks like this, right? So here's you, here's all the people that are following you, here's the people who follow them. And so then we can look at how information spreads. We can also look at who is an influencer. So eigenvector centrality measures help us understand who has the most influence on the network, where we represent each person here as a node, and these edges or these lines connect and show the spread of information. So we can actually take our information here. If we had information on multiple people, so we have your followers, the people who are following them, we have the people you are following, and the people who they are following, we can start to build a big network. Which is why when Facebook, for example, made it easy for people to basically pull large amounts of data about everybody from Facebook itself, since then they've cracked down, so you can get you, but it's very difficult. You have to apply for with a research proposal to get bigger amounts of data. What you could do is you could build an entire network and understand all of these people and how information spreads, which gets us to things like Cambridge Analytica, understanding and influencing elections like in the UK, because they knew all about people and how people interacted with others, who they interacted with. You could identify the influencers, and so you could campaign and you could advertise particularly to target certain groups to help spread the message. And so we'll look more as we get to those network models on how we can map that out. But if we were going to do that with, say, our Twitter or X data, we would need followers and their followers, and we would need following and the people following them. All right, so look out for those extra videos where we start to analyze some of this type of data.